Hello. We're starting chapter 8, and chapter 8 talks about sequences. So, 8.1, we're going to start with sequences and summation notation. Um, First, we're going to define a sequence. So, an infinite sequence, AN, is a function whose domain is the set of positive integers. The function values or terms of the sequence are represented by a sub 1, a sub 2, a3, a4, all the way to an. And so sequences whose domains consist only of the first n positive integers are called finite sequences. So let's look at an example, writing terms of a sequence from a general term. So we need to write first four terms of the sequence whose nth term or general term is given a sub n equals 2n plus 5. So this is our general term or nth term, either one. Um, we're going to write the first term. So instead of the n, we're going to write 1. So that means that this is going to be 2 times 1 plus 5, which is 7. Second term, so we're subbing in with 2. 2 times 2 plus 5 is 9. Third term is going to be 11. And fourth term is going to be 13. So the first four terms are 7, 9, 11, and 13 for this one. Okay, let's look at another one. Again, we're writing the first four terms of the sequence whose nth or general term is given right here. So again, first four terms. So a n equals negative 1 to the power of n divided by 2 to the power of n minus 1. Okay, first term, negative 1 to the power of 1, 2 to the power of 1 minus 1. This is going to be negative 1 divided by 1, which is negative 1. Second term, we're subbing 2 where the n is, 2 to the power of 2 minus 1. So we get 1/3. Third term, negative 1 to the power of 3, 2 to the power of 3 minus 1, negative 1/7. And fourth term is negative 1 to the power of 4, 2 to the power of 4 minus 1, which is 1/15. So the first four terms are negative 1, negative 1, 1/3, negative 1/7, and 1/15. Okay, next we're going to talk about recursion formulas. So a recursion formula defines the nth term of a sequence as a function of the previous term. So if we look at this example, find the first four terms of the sequence in which the first term equals 3 and then the general term, you can see that there's that uh, a sub n minus 1. So that is the previous term. And n is greater than or equal to 2. So we know that our first term is 3. That's always given in these. Our second term is going to be 2a subbing in with the 2. So 2 minus 1 plus 5. So this is going to be 2 times the first term plus 5. Well, we know that the first term is 3. So we're going to rewrite 2 times 3 plus 5, and we get 11. excuse me, third term is going to be 2 times a 3 minus 1 plus 5. So 2 times the second term plus 5. Well, our second term is right here, which is 11. So 2 times 11 plus 5 is going to be 27. Fourth term, 2 times a sub 4 minus 1 plus 5. So 2 times the third term plus 5. Third term is 27. So 2 times 27 plus 5 equals 59. So there's our the first 4 terms. Okay, next we're going to talk about factorial notation. So if n is a positive integer, the notation in factorial is the product of all positive integers from n down through 1. Um, so it looks like this right here. So for example, if we have, let's say 5 factorial, it would be 5 times 4 times 3 times 2 times 1, which is 120. Um, there is the factorial notation on your calculator. It is at the not like the second row, there's a PRB. If you press um, the PRB, you'll see that there's NPR, NCR, and then the factorial notation. So what you would do is you would type in 5, hit PRB, choose the factorial notation, and hit enter, and you get your answer. Now, 0 factorial is always 1. Make sure that you're aware of that. All right, let's look at an example with the finding terms of a sequence involving factorials. So, right, the first 4 terms of the sequence whose nth term is this right here. So we're going to go ahead and replace those. Um, the first term is going to be 20 divided by 1 plus 1 factorial. So 20 divided by 2 factorial. Well, 2 factorial is 2 times 1. Now we can do 20 divided by 2, or we can simplify by 2. 2 divided by 2 is 1. 20 divided by 2 is 10. So it's going to be 10 divided by 1, which is 10. Second term is going to be 20 over 2 plus 1 factorial notation. So 20 over 3 factorial notation, or factorial, sorry. Yeah, 20 divided by 3 factorial. So 20 divided by 3 times 2 times 1. Now, again, I can divide 2 by 2, which is 1, and 20 divided by 2. So I can divide both the top and the bottom by 2, and I get 10 on the top. So I get 10 divided by 3 times 1 times 1, which is 3. So 10 thirds is our second term. Yes, we could have done 20 over 6 and then divided both of these by 2, and we would have gotten the 10 thirds as well. Sometimes it's just easier to simplify before you do the calculations. Plus, the calculations are going to be easier when you simplify before that. But there will be, like with the factorial, there will be ones where you're not going to be able to do the calculations with the calculator because the factorials get so big, large that it's easier to just simplify before you do the calculation. Okay, third term is 20 divided by 3 plus 1 factorial. So 20 divided by 4 factorial. That is the same thing as 20 divided by 4 times 3 times 2 times 1. Okay, 20 is divisible by 4, so 4 divided by 4 is 1, and 20 divided by 4 is 5. So on the top we've got 5, and on the bottom 3 times 2 times 1 times 1 is 6. So we get 5/6. Fourth term is going to be 20 divided by 4 plus 1 factorial. So 20 divided by 5 factorial, which is the same thing as 20 divided by 5 times 4 times 3 times 2 times 1. Okay, so 20 is divisible by 5. 20 divided by 5 is 4. 5 divided by 5 is 1. Well, we have a 4 on the denominator, so we can divide by 4 again. 4 divided by 4 is 1, and 4 divided by 4 is 1. So our numerator is going to be 1, and our denominator, 1 times 1 times 3 times 2 times 1 is 6. Gets a lot easier than doing the 5 times 4 times 3 times 2 times 1, and then simplifying. Okay, next we're going to look at summation notation. So the sum of the first n terms of a sequence is represented by the summation notation. And um, that it's a capital sigma. So it's like this should be kind of a um, kind of an arc between the two lines. And we will have an I, which is the index of summation. So we'll have I here, and it starts somewhere. For example, we can say that I starts um, from 1, and then n is the upper limit of the summation. So n goes over here, and then we'll have a sub I. What this means is that we are adding first term plus second term plus third term plus fourth term plus all the way up to the nth term. So the 3 dots is the ellipsis, which means that all the numbers in between 4 and n are going to be there. Okay, next it's asking us to expand and evaluate the sum. Our sum for this one is I equals 1. That is, so the lower limit is 1, our upper limit is 6, and it's 2I squared. So we're going to rewrite this. So our first term is going to be 2 times, we're subbing in 1 where the I is, I squared. And then we're adding the second term, which would be 2 times. Well, our next term is going to be 2. So I is going to be 2. We're adding the next third term, I is going to be 3. Fourth term, I is going to be 4. Fifth term, I is going to be 5. And then the sixth term is the last one because we have the 6 as the upper limit. So it's going to be 2 times 6 to the power of 2. Okay, and now we need to do the exponents first. Well, 1 squared is 1, so this one is 2. 2 times 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25, and 6 squared is 36. And now, of course, you can plug that whole thing in the calculator. So 2 plus 8 plus 18 plus 32 plus 50 plus 72 equals 182. Okay, next sum that we are evaluating is, instead of I, we're actually going to use the letter K. And our lower limit is 3, our upper limit is 5. And it's 2 to the power of K minus 3. And all that has to be inside parentheses to show that it's the whole thing is part of the sum. If it looked like, actually, let me write it over here. So if instead we wrote it without the parentheses, that would mean that we are, the 2 to the power of k is the only thing that's part of the sum. So this would be 2 to the power of 3 plus 2 to the power of 4 plus 2 to the power of 5 minus 3. Instead, what we've got here is we're starting 2 to the power of 3 minus 3 plus, so that's our first term. Um, Next, we've got 2 to the power of 4 minus 3, and then our last one is going to be 2 to the power of 5 minus 3 because we're only going up to 5. Okay, 8 minus 3 plus 16 minus 3 plus 32 minus 3. So we get 5 plus 13 plus 29 equals 47. Okay, let's look at this one here. If we do this, 2 to the power of 3 is 8, 2 to the power of 4 is 16, and 2 to the power of 5 is 32 minus 3. Well, 8 plus 16 is 24. 56 minus 3 is 53. Okay, come on. 53. So you can see that the answers are different. Okay, next, some notation that we're gonna evaluate, or summation notation, is our lower limit is 1 and our upper limit is 5, and we only have 4 here. Okay, so we don't have an I. All we have is a 4. So this means that we are going to be adding 4 plus 4 plus 4 plus 4 plus 4. So this is I equals 1, I equals 2, I equals 3, I equals 4, and I equals 5. We don't, I mean, there's no I, so it doesn't change. Every single term is 4. So same thing as 5 times 4, which is 20. Okay, that's it for this lesson. Let me know if you have any questions. Bye.